Hey team, welcome back to my channel. In this video, we're going to be looking at the data type number for Typescript. Hope you enjoy this video. Here you can see I'm saying constant pi equals 3.1415 all the way to 46, 20 digits of precision. When I say console.log type of pi, it should return me number. Now once I have assigned pi to a number, that is the only data type pi will ever use. And we use this as a constant, so there is even no changing this value. If we use toFixed, notice it rounds at the third digit. So here, since that's a 1, when I say fix 2, that will stay 4. But when I say round at 3, notice it's a 5, so that should go to 2. Let's see what happens here. So 2 is 14, 3 is 142. You see how the 5 made it round up. And then 14, 16 because of the 9, and 14, 15, 9. The 2 did not do anything. toPrecision looks at the number in general and then does rounding and limits the size to whatever this number is. So for instance, when we say 1, it would just use the first number here. Let's run this and see what happens. So notice 1 is just 3, 2, 3.1. I think you see it now. In this example, I'm saying let n equals 12. And then we're going to print out n, which is 12. And then I'm going to show you the type. Notice we got 12. We told it it's a number. But now that I've assigned 12 to n can only ever be a number. If I try to assign the string 12 to n, notice it's got squigglies and it says type string is not assignable to type number. So that's pretty smart. So once you defined a variable, it is what its data type evaluates to. Here you can see I'm saying let n be of type number, and I'm going to initialize the value to 200. And then n2 is a number, and I'm going to initialize that to 0. And then I say n2 equals n plus plus. This is called post increment. So what happens when you say post increment? See this equal signs? What it does is it actually takes the value n, makes the assignment, and then does the post increment. So what do you think the value would be here? It would be 200 or 201? 200. Pre-increment pretty much just says increment n first and then do an assignment. So here we're saying 200, 201, do the assignment, 201. Now let's convert a string to an integer. Notice line 1, let s equal the string 99. On line 6, I say n, which is a number, equals parseInt of s. Then on line 7, I'm saying, is that not a number? Now if that is true, I print out like that error message. If it's not, I come down and show you n is 99 and the data type is number. In this example, you can see s equals the string s99. Then I'm trying to use on line 6 parseInt. Well, that will fail. On line 7, I said is not a number. That would be true. So there you get cannot convert to an integer. In this example, we're saying let s equal the string 9.47. Line 6, we're saying n equals parseFloat of that s. I'm going to take 9.47, the string, and convert it to a float. That's going to evaluate is not a number to false. So it would execute the bottom line. Notice the type is still of type number. In this example, we're going to let s equal the string s 9.47. Now look at the message on line 5. If the first character cannot be converted, NaN, not a number, is returned. So on line 7, I say n equals parseFloat of that s. Now it's going to fail on that s character. So that's going to evaluate to true. And that is why we get that error message. Now we can assign hexadecimal values to a number. Notice here I'm saying let n of type number equal the hex value ff. ff is 255. Let's see that. Notice 255. Now we can also convert that n to different bases as well. So here you can see I'm going to get it back into hex, and I can say 0x, and this is just the beginning of it. And then I'm going to say that n to string base 16, base 10, base 8, and base 2. So that's hex, decimal, octal, and binary. So notice ff is 255. It's ff in hex, 377 in octal, and it is 8 ones, which will be 255 in binary. And of course, I can go the other way. I can start with binary and then work my way to the other bases as well. You see that binary 1010 is 10. 10 in hex is A, and octal is 12, and then back to binary. In this example, you can see that I'm assigned max to number.maxSafeInteger. These are like constants, so we have a max and a min. I will print those. And the max number is pretty much 9 quadrillion, and then a bunch of other little numbers. Then on line 9, notice I'm going to try to pre-increment max. So I'm going to take this 991, and do you think it will go to 992? Yes or no? Let's run it. It sure did. It incremented to 992. So this is just a safe number. We could have said max value and min value. Let's run that. And notice the values go up to E308. In this example, all you can see is I'm going to do different bases. I'm taking in hexadecimal, plusing a binary. Then I'm going to show you the results in hex, decimal, and binary. So F is 15. This binary value is 3, so 15 plus 3 should be 18. And there you have the data type number. And there you have it, team, the data type number for TypeScript. Now, this right here is a very easy data type to understand. You can either take in a number that has a decimal or doesn't have a decimal. You know, we used a number pi that had, 20, but there are millions available. You've seen the functions like fixed and, precision, the toString to be able to convert it from the hex, binary, octal, and decimal. And those are all great functions. And this is a great skill to have. You also learn that once you declare a variable of type number, you just can't go and throw a string or a boolean at it. It's number only. And those are the rules. And now you know the rules. I hope you enjoyed this video, and I look forward to seeing you back in my next video. Have a great weekend. Adios.